Tonight we are examining a narrow slice of observational data captured during a single extended telescope session. This is not a discovery announcement, it is not a conclusion, it is an attempt to slow the footage down, separate what was recorded from what was inferred, and understand what can and cannot be said based on the available evidence. The material comes from Ray, an astrophotographer who routinely documents faint objects using privately operated equipment. In this case, Ray was tracking a comet over several hours during a live imaging session. What makes this observation worth examining is not a single dramatic frame, it is the repeated appearance of specific features across dozens of images, combined with Ray's own hesitation to declare what those features represent. What follows is an evidence-based walkthrough of what Ray captured, how he processed it, what fits within standard comet behavior, and where uncertainty remains. We begin with why this particular observation stands out. Ray's footage shows a comet exhibiting a long anti-tail and possible jet curvature across many frames. These features appear before and after image cleanup and during comet alignment. At the same time, Ray repeatedly cautions that some of what appears in the images could be noise or processing artifacts. That tension matters. Repeatability suggests structure. Uncertainty limits interpretation. Both must be held at once. Ray was not searching for anomalies. He was documenting a faint comet during a routine observation window. The unusual aspect is not the presence of a tail or jets. Those are expected. It is the apparent persistence and length of the anti-tail, combined with hints of curvature in the jet structure, that draw attention. To understand that, we need to look at what Ray actually did. According to Ray's observations, imaging began around midnight and continued until roughly 4 to 4:30 in the morning. Earlier attempts were made between about 9:45 at night and midnight, but Ray explains that those images were blurry due to light pollution and low visibility. The comet was present but not clearly resolved. After midnight, conditions improved. The comet rose higher in the sky, atmospheric interference decreased, image clarity increased. Over the course of the session, Ray captured approximately 177 images. This volume matters. Single frames are vulnerable to noise. Dozens of frames allow for comparison. Patterns that persist across many images are harder to dismiss outright, though not impossible to misinterpret. Ray explains that after capturing the images, he cleaned them. This included noise reduction, minor sharpening, and cropping around the comet itself. He does not describe aggressive manipulation. He describes standard astrophotography cleanup intended to improve clarity rather than alter structure. Ray also compares these images with earlier data from roughly 1 week prior. That comparison introduces a time dimension. It allows him to ask whether certain features appear only once or recur over time. Throughout the footage, Ray points out several visual features: a tail extending away from the comet nucleus, or an anti-tail extending in the opposite direction, visible outgassing near the core, jet-like structures projecting outward, and in some frames a subtle arc or curve within one of the jets. Ray is careful with his language. He does not declare that the curvature is real. He explicitly wonders whether it might be noise. That caution is important, and we will return to it. Before examining the features themselves, the timing of this observation needs context. Ray notes that the comet is becoming dimmer over time. He estimates that within a month it may be difficult to observe at all, even with powerful telescopes. This shrinking window limits the ability to gather follow-up data. Ray also demonstrates how quickly the comet is moving relative to Jupiter. Using time progression, he shows that within roughly 1 month, the comet travels a large apparent distance, closing in toward Jupiter's position. This rapid motion is not unusual for comets, but it emphasizes how quickly observational conditions change. In practical terms, this means that whatever is happening now may not be observable under the same conditions later. That matters because repeatability over time is one of the strongest tools available in observational astronomy. With that context, we can examine what standard explanations would predict. Mainstream comet science expects jets. As comets approach the sun, volatile materials sublimate. Gas and dust escape through vents, forming jets. The orientation and appearance of these jets can change as the nucleus rotates. Tails can appear longer or shorter depending on viewing angle. Anti-tails are also known phenomena. They occur when dust particles lie along the comet's orbital plane and are viewed edge-on from Earth. Under the right geometry, an anti-tail can appear to point toward the sun. Image artifacts are also common. Noise, pixel sensitivity, stacking errors, and alignment processes can all create or exaggerate apparent structure. Apparent curvature can emerge when faint features are pushed near detection limits. On paper, all of this fits comfortably within known physics. However, there is a gap between what is theoretically possible and what is directly supported by Ray's footage. Ray observes similar tail length and jet features across multiple nights. He sees them live before processing. He sees them again after cleanup. He sees them during comet alignment. That does not prove the features are physical, but it complicates the idea that they are random noise appearing once. This is where the analysis pivots. Accepting standard explanations does not automatically resolve every observation. It simply provides a baseline. The first contradiction Ray himself raises involves image cleanup. He states that after cleaning the images, some of the curvature becomes less obvious. That would support the idea of noise, yet when he steps through individual frames, the curved feature appears again in specific images. If the feature were purely random noise, we would expect it to appear inconsistently without repeating shape or location. Instead, Ray notes that it seems to recur in roughly the same region relative to the nucleus in certain frames. The second contradiction concerns the antitail. Ray references an external paper discussing structured jets and antitails observed in space telescope data. He does not claim authority from that paper. He simply notes that the unusually long antitail described there resembles what he sees in his own images. Importantly, Ray observed this feature before referencing that paper. He points out that he noticed the long tail earlier, and even showed it during a live stream. That reduces the likelihood that he is seeing what he expects to see based on external claims. The third contradiction emerges during comet alignment. Ray explains that comet alignment keeps the comet fixed in place while allowing stars to move. This technique helps distinguish cometary structure from background motion. When Ray runs this process, the comet remains stable while internal features appear to shift or change shape across frames. He notices what looks like a pronounced tail segment and slight curvature in one or two images. At the same time, he expresses uncertainty about whether this represents real structure or residual noise. This is not a dramatic reveal, it is a subtle inconsistency that refuses to resolve cleanly. At this point, it is appropriate to outline plausible natural working theories. These are not conclusions, they are possibilities consistent with known physics. One possibility is rotational modulation. If the comet nucleus is rotating, jets can sweep through space, producing apparent arcs or curves when viewed across multiple frames. Another possibility is changing illumination. As the comet's orientation relative to the Sun and Earth shifts, different jets may become visible or fade, creating the impression of movement or curvature. Perspective effects also matter. As the comet moves rapidly relative to Earth, small changes in viewing angle can alter how dust structures project onto the image plane. Layered dust emission could also contribute. If different particle sizes are released at different times, overlapping dust sheets could form extended antitails that appear longer than expected. Finally, instrument sensitivity and processing thresholds can amplify faint features that are real but near the noise floor, making them appear intermittently. All of these explanations are plausible. None can be confirmed with the current data, which brings us to what is missing. Ray does not provide photometric measurements. Brightness changes are described qualitatively, not quantified. There is no spectral data. Without spectroscopy, we cannot identify gas composition or velocity profiles within the jets. There is no independent confirmation from other observers. Single-site observations are valuable but limited. There is no statistical analysis of frame-to-frame consistency. Ray visually inspects the data but does not perform automated validation. These gaps do not invalidate the observation. They define its limits. Before closing, we need to integrate Ray's own words at key moments because they anchor the analysis to the source footage.
We took pictures from, I believe, 12 in the midnight till 4:30 in the morning. Somewhere at 4:30, I could not take pictures anymore. The comet was on the east side, almost close to 9:45 in the night or 10 o'clock. But anywhere between 10 to midnight, I mean, the pictures were a little bit blurry because light pollution and the comet was not clear. But once it get to the midnight, the pictures started becoming more and more clear, and we captured several of those pictures. I believe I captured close to like 177 pictures, something like that.
This clip establishes that we are not dealing with a brief or isolated capture. The dataset spans hours and includes a large number of images.
Cleaned up those pictures. I'll show you the pictures that I took. There is a recent paper from Avi on the structured jets that he was noticing, looking at the Hubble pictures across the time period.
This clip shows that Ray's observation of the antitail did not originate from a single session.
It's getting very interesting. We may not be able to see this comet very clearly maybe a month from now. That's my guess. It will become a very tiny dot, and I don't know if we will get a chance to have great opportunity to see when it is passing Jupiter. The interesting part I noticed is this comet is running so fast, is moving so fast. I shouldn't call it running, but it is moving so fast.
This clip captures the core ambiguity. Something appears, Ray sees it, Ray questions it. At no point does Ray claim certainty. That restraint is important. As the comet continues to dim and move away, opportunities for further observation narrow. The data we have is incomplete, but it is not meaningless. It shows repeatable features that fit within known comet behavior while also resisting easy dismissal as random noise. This is where the analysis must end. Not with a conclusion, but with a boundary. Ray's dataset does not prove that anything unusual is occurring. It also does not allow us to confidently dismiss every feature as artifact. The images sit in an intermediate space where natural explanations remain plausible, but confirmation requires data that does not exist. The observation window is closing. The comet is fading. Without additional measurements, what remains is a record of what was seen, how it was processed, and what cannot yet be resolved. That uncertainty is not a failure of analysis. It is an honest reflection of the limits of observation.